Hello, welcome to my command line slash bedroom. Um, I wanted to put together a little video to film a kind of pre-alpha in-dev look at a botnet I've been writing. It's something I've had a big interest in for a very, very long time. I've about the Mirai botnet, and basically I just have a real fascination, interest with the kind of distributed systems problem, the security around them, and I work in security, and I enjoy programming, and I wanted to put one together as a learning experience for myself, possibly use them in some red team and blue team exercises moving forward, and just have a bit of fun with it. I've been writing this for a while now, kind of on the train, and over the Christmas and New Year's break I had some time to actually write kind of more of it and get it to a state where it's working, so I just wanted to use this video just to kind of show it off and see where I am. So it's in a private repository under my GitHub, and it's called boTTom, which is kind of a joke on it's my name Tom, and it's a botnet, and it's Tom's bot, or boTTom, and it's just kind of a really silly name. And the idea was to create a reliable, secure, simple cross-platform botnet. The simple part has gone out the window quite quickly, but the secure and cross-platform nature of it is definitely true. And the other thing I wanted this to kind of set it apart was I wanted it to be really easy to set up and deploy, which is what we're also going to cover in this demonstration. I've put together a Google Slides just to kind of give an overview of the architecture of it, as I think is a little bit different to kind of the other systems on the market at the moment. So starting off at the heart, there's a Postgres kind of back-end database which stores all the bot registration data and commands and any loot that are exfiltrated from the victims. We have the Wrangler, which is the heart of the botnet, but the security design for the Wrangler is so that any part of the system can be compromised, and even though the Wrangler orchestrates and manages the bots, a failure of the Wrangler can only be a availability issue. All commands issued to bots are signed by a controller, and the Wrangler can accept connections from bots, but it can't implicitly direct them to do anything. When you initialize a campaign, a botnet master key is generated, and this is encrypted and stored at rest with the Wrangler, and needs to be decrypted by a controller which is running on the attacker's machine in order to execute commands. So this provides some separation. Also, the Wrangler is tied quite closely to the Postgres database, but the other components, such as the bridge and the builder, which I'll touch on in a second, all communicate with the Wrangler through dedicated SSH connections. The idea behind this is you can quickly and easily stand up this cloud hosting on like a EC2 instance or a droplet with DigitalOcean. And it's all contained in a single Docker Compose file, so you can just do Docker Compose up and it's going to put everything together. But the idea is you don't have to do it like that. Because of these SSH connections, you can stretch all the different components over, like you could tunnel them over Tor, you could put them in different cloud hosting components, you can have more than one builder, you can have more than one bridge, and architecturally there's no reason why you can't have more than one Wrangler. Just at the moment it's a lot simpler to just have one of them. So that's kind of the attacker's cloud hosting. What are these different components to do? As I said, the Wrangler wrangles the bots, it accepts their connections, it just kind of acts as the middleman. The builder actually builds bots, and the idea is that you have a stager, which is some sort of shell script or kind of your first hook into a victim, and the stager will call over HTTP to the builder. The wrangler will generate new public-private key pairs for a bot, and its configuration file will send it to the builder, and then the builder will then compile the executable. It will pack the executable and do any obfuscation it needs to do, and then provide unique binaries to every single installation of a bot within this botnet. So here we can see the bot running on the victim's machine. It's a packed executable. It's got an encrypted config which is dynamically decrypted at runtime and tells the bot where to connect to. It contains its public and private key pair that it uses to identify itself. It contains the controller's public key so it can verify the commands that are sent to it, and it also contains the wrangler's public key so an end-to-end connection can be established. In order for the bots to talk to the network, there needs to be some sort of command and control infrastructure. Later on, I'm looking at moving this to use some sort of fast flux system, but at the moment it's just a single hard-coded command and control server address. In order to facilitate that connection, there's an extra feature called a bridge. And what the bridge does is it allows the bots to communicate over a variety of different obfuscation communication methods. The one that I've implemented at the moment is basically a HTTP tunneled over TLS, known as HTTPS, with a WebSocket connection. And that's what it would look like from the outside interface, but what's actually happening over this bridge is it's using to tunnel the main SSH connection that the bots use to communicate. So what this means is later on you could implement something over DNS, you could implement something over ICMP ping. It gives a variety of different communication methods without affecting the underlying system, so it allows for expansion moving forward. So you have a stager, builds a bot, wrangler generates all the key material, stores it in Postgres, bot then runs, establishes an SSH connection, establishes a WebSocket connection to the bridge then strips back that connection and exposes the raw SSH connection, which then connects to the wrangler. So the bot's connection to the wrangler is kind of uninterrupted, it's end to end. Then, using the builder, an attacker can generate a controller binary, and the controller binary is again exactly the same as the bot binary, but instead provides a command line interface to manage the botnet. The important difference is when the controller connects through the same mechanism into the bridge, the wrangler checks the Postgres database to see if that bot's public-private key pair is flagged with the isController flag. If it is, then it is authorized to basically enter a different pathway in the code to issue commands to bots and have different requests. The wrangler then takes the encrypted master key and sends it to the controller, where it is decrypted in memory. You get prompted for a password, you type the password in, and then this is held in memory and is used to sign commands to and from the botnet and the bots. The idea of this is even if you get hold of the attacker's machine, you don't have access to anything. The password is in the person's head, and even if you compromise the cloud hosting service, this key is just encrypted on the disk and remains encrypted on the disk. And I'm actually using the age encryption system, which if you have a strong passphrase for this encrypted master key, it will be incredibly difficult to decrypt in a post-compromise scenario. So that's kind of the general architecture of the system, in a bit of a rambling put together. So what I'm going to do now is we're going to attempt to put it together live. So I have the local repository here, which I am working on because this is still in active development. But what I'm going to do is I'm going to connect to a server that I've created on the cloud. So this is using DigitalOcean's droplet functions. I've just created a VMS in the cloud and I've connected to it, and that's the IP address there. I'm using SSH-A in this case to forward my SSH keys, because this is hosted in a GitHub private repository. I need the keys in order to authenticate them. So there's nothing here at the moment, so I'm just going to git clone the repository. There it is there. CD into it, and then I'm just going to cat the readme file here. And you can see the quick start is clone the repository and then set up the campaign. So I'm going to run this command here, and what this init campaign script does is it sets up the various keys required to create the campaign. So once that's built, I'm going to run the init campaign command. And as you can see, this program is used to initialize the botnet campaign. It will generate the required keys and passwords. What would you like the campaign to be called? So I'm going to call it Cloud Test, because testing in the cloud. I know, creative name. Where would you like the campaign to be hosted? So in this case, it is hosted in the cloud. So I'm going to do http:// and then I'm going to give it the address of this droplet, and then I'm going to again give it the port 8080, which at the moment in Docker Compose every component is running on a different port. The end solution to this is everything will be put behind a Nginx proxy, but this is just what I have at the moment. So I'm going to do that. We're going to need a password to encrypt the master encryption key for this. I'm just going to go with a very short password. I wouldn't recommend that, but I'm going to do it for this demo. And there we go. So this generates the config file, a UUID for the campaign, the URL. It generates and encrypts the botmaster key pair, and then for each component within the botnet, their own key pair is generated. So this allows them to all have mutual kind of zero trust connection between them, and means the components can be spread out into different places. And there we can say the campaign is ready for launch. So if I have a look in that campaign directory, we can see all the different private and public key pairs, and then we can see the botmaster is encrypted. So once that's all done, if we return to the README, we have this setup infrastructure command. So this is going to instruct Docker build, or Docker Compose, sorry. If we take a look at the Docker Compose file here, we can see we have a bridge, we have a builder, a wrangler, database, and a database admin panel, which is only really used for development. But these are all the separate components, and then they all have their own build files. And you'll notice inside each of the build files for these separate containers, only the required public and private key pairs are copied into these containers. So if these systems were put on different hosts and there was a compromise, you know what parts are being compromised. So I'm just going to start up the infrastructure now. This is going to take a bit of time. Not that there's a lot of code to build, but because all the builds are done inside Docker containers, it just takes a little bit. So I'm probably going to fast forward this in the video, but we'll just give it a moment. So there we go. It's built all the containers, start everything up. So we're going to do docker ps. Gonna spell it right. There we go. Everything looks like it's up. So then we're going to do a docker compose logs and there we go. So we can see the bridge starting here, and it's created that method for the HTTP WebSockets connection, listening on 8080, online and ready. We can see the builder here is starting up, and it is establishing an SSH connection to the Wrangler. And we can see a few connection failed attempts here because Docker Compose starts everything up at the same time. But that builder is online and ready, and then it starts a web server where stagers can come in and build different bots. Something I didn't mention before is the builder will build bots for all platforms, so Mac, Windows and Linux, which is kind of the advantage of everything being written in Go because it has easy cross platforms. Database admin we don't really care about, and we can see Postgres basically initializing here. When the Wrangler starts up, it says what campaign it's configured for, it establishes a connection to the database, it installs the database schema, and then it starts up kind of the heart and show here, which is its own internal SSH server, which is online and ready. And here we can see different components connecting in. So we can see the builder here, authentication attempt, authenticate with public key, establish a SSH connection. And this is just more of the database stuff. Database is online. We can see the bridge here doing its connection and more bridge stuff. So that looks fairly good. So what we're going to do now is I'm going to split this tab horizontally, and I'm going to go to my downloads, and here I'm going to call wget, and this is the IP of our host here of the attacker's infrastructure where the botnet is running. And I'm going to port 8083, which is our builder, and I'm going to ask it for a controller so I can control this botnet. I'm going to ask it for a download, and I'm going to ask for the Linux operating system, which needs to be in lowercase l. So I'm going to do that, and we're just going to wait. So all of these builds are run dynamically over HTTP when they're requested, so they do take a little bit of time to complete. In the future, probably going to look at caching the building of these bots to make them a bit faster. However, when I run this locally on my machine, it runs incredibly quick, so the other solution is just get a better cloud server to run this on. I'm cheaping out here, it's just a cheap 1 gig one. So we're just going to wait for the response. There it is, it's downloading it. Download complete. So I'm just going to scroll up here just so we can see some of the logging that's happened here. So this is the Wrangler receives a connection from the builder and the request for the builder control channel. It's requesting a new controller, generating a new controller. It generates a new key pair for it, and it uses the public key to generate a ID for the controller or bot. So the IDs are basically fingerprints of the key pairs. So it's generated, it then creates and encrypts the config bundle. We can see here, it's very verbose logging, but we can see the SSH connection goes down. Building and packing the controller. I haven't actually implemented any proper packing at the moment, so these are just straight go build binaries, and you can see the go build command being set here with the go OS being set to Linux. And we can see here I'm using the go -X flag to pass in the configuration, which is the encrypted config basically. But we can see build was okay, and it's using the Gin framework to serve these connections. But we can see all that's done successfully, and we've downloaded it here. So I'm going to rename this to more appropriately, which is going to be controller. I'm going to chmod it, and then I'm going to run the controller. And what we're going to see here is it dynamically loads and decrypts its config file, and then all of the systems basically have this line saying, hello, this is my identity, I'm configured for this campaign. It attempts to establish a connection to the command and control using that bridge method that I discussed. This line is basically that layer 4 connection has been established, and then it tunnels the SSH connection over the top of it. SSH connection established and authorized by the network, so the network reserves a right to kick out or ban any bots that are misbehaving, or you feel that they might have been compromised by a security researcher. Requesting channels, and then here we're requesting that botmaster's encrypted key. And here we can see the bridge receiving the connection, forwarding the connection to the Wrangler accepting the connection. We can see the different authentication things here, and then we have a big line saying the controller has authenticated. And we can see the different channels being open here with the different control channels. And this is kind of the advantage of using SSH. It means you can very easily split all these different connections down different channels and keep the code paths separate. So I'm just going to authenticate, and then we get a command shell. And here we have a few options. We can connect to a bot, we can kick a bot from the network. As you can see, this was mostly used because I needed a bit of debugging help. As it is misbehaving, it will reconnect in a hopefully good state. And we can see there's a SFTP function, so you can transfer files to and from a bot, and the command we're going to use at the moment is list, so we're going to say list active bots, and here we can see there are no active bots currently because we need some new ones to connect to the network. Something I wanted to highlight though here is the bot ID is the generated key pair fingerprint that I said. So this stage here is called bot registration. So when a bot connects, it basically scans the host operating system and says to the network, hi, I'd like to connect, here's my registration details. And this allows you to build a database of all the different bots that have connected and then search on them by like, is this user root? Give me all of those ones, give me all the Windows ones, give me all the Mac ones. Or you can search by IP address if you want to. An interesting feature as well is host ID. So host ID allows the bot scans the system that is on, it gathers different bits of information, and then it puts it through a SHA-256 sum to generate kind of a fingerprint of the host, and then this is reported in as part of the registration details. So this means that if multiple bots infect the same host through some way, then you can work out basically. So this is a deduplication effort, but it also allows to do fingerprinting of sandboxed environments. So if this is running in a known sandbox, then they would all have the same host IDs, and then you can ban a particular host ID or a particular bot ID that is misbehaving, and then they can't enter your network, and it allows you to control security researchers or maybe you want to reject by IP address because you don't want to target Russian assets or UK or something like that. Or maybe if the host name contains something like NHS, then you wouldn't run. So that's the whole point of the bot registration segment of it. So the next thing we're going to do is we're going to build and deploy a bot. So if we go back to the architectural diagram here, what I've done for this is I have a USB rubber ducky on here, and this is going to pretend to be a keyboard. I'm going to plug it into a Windows-based machine. It's going to open PowerShell, and the PowerShell script is very simple. If I go back to the command line here, and if we have a look at the USB rubber ducky stager, we have this very simple PowerShell script, which basically says, go to the builder, get me a bot for Windows, save it to the app data directory, call it bot.exe, and then just start it. It's very simple. It's very blatant. Obviously, you put a lot more care into this, but that's the general idea. And then I've taken that and I've written some ducky script for it, which is going to be running on this USB rubber ducky. And yeah, let's go and give that a go. So this is my old laptop, and here is the USB rubber ducky. So I'm just going to plug it in to the computer like that.
Target acquired.
And then we're just going to film the screen here, and we can see that it's going to open the command prompt. It's then going to type out basically that PowerShell script that we saw before. It's going to hit enter and it's going to disappear. So now, hopefully, in a few minutes, we will see that the bot will connect and we can hopefully connect to this machine. Now back at my main computer, we can see the builder here is requesting to build a bot, generating the bot key pair, doing a fingerprint thing. The Wrangler's generated a new bot. Here we are now running on Windows, so it's done the bot build process, build OK. You can see it took 1 minute and 11 seconds. Thankfully the HTTP request didn't time out. So the file was successfully generated, and then it was saved on the Windows machine in app data, then executed. And then we can see just momentarily afterwards, we can see a connection received from the bridge, which is forwarded to the Wrangler, and here we can see basically the bot coming in and authenticating, handling user for bot control channel. Wrangler bot has been added to the connection pool, and then it's handling that bot registration that I mentioned. So now we can run the controller. We can type in our password, and now I can say list active, and hopefully there we go. So we have, that's the bot ID, we have the user, which in this case is myself because it's running on my ThinkPad, the host name, the operating system, the host ID that I mentioned, which has been automatically generated, and we can see the IP addresses. Also, I'd like to draw attention to this line here about bot master command executive active. This is because I said list active bots. So whenever this line is shown, the command list active is digitally signed, sent to the Wrangler. The Wrangler then verifies it before executing it. So now I can connect directly to this bot with the connect command. When I do the connect command, we can see here there's a connect channel. So the way that this works is the bot generates a separate SSH channel connection up to the Wrangler. Actually, probably make a lot more sense if I just went back to this thing. So the way that this works, the bot generates a connection up to the Wrangler, and then the controller generates a connection up to the Wrangler as well. And then the Wrangler sticks these two connections together. Then the bot runs its own SSH server internally, which then the controller then connects all the way through the Wrangler, all the way back through its networking directly to the bot. So when you run the connect command, it is a end-to-end encrypted connection between the controller running on your computer and the bot running on that victim. The Wrangler can't do anything to interrupt or change this connection, because all of the keys are verified, because the bot knows the controller's key pair and vice versa. So that's kind of, and also the fingerprint of that key pair is the bot's ID, which provides an additional layer of security. So here we can see that I'm connected. You can run a help command, and the bots have a bit more of an interesting command line. So we can do hello. It says hello, I am this bot running. There's the process ID as myself, aka myself, on this laptop, blah blah blah. We can do an ID command, which pulls out more information about my different IDs and SIDs on Windows, and we can see the different groups that I'm a member of. We can do a ping, which is just kind of a ping pong thing. We can run a status, which goes into more information about which command and control network and campaign it's configured for. We can see this is the ID of the key pair built into this bot, the host's identity, operating system, etc. And then we can do something more interesting, like open a shell. So now we're in the glorious Windows command prompt, and we can do something like MSG to display a pop-up message, username, hello. So if I execute that, so there we can see the little hello pop up on the computer. So that displays that the shell is working. So if I disconnect from the shell, we can see the shell has exited. We can see the current working directory of the bot, which is there. We can move that to the desktop, so we can see our current working directory is the desktop, and then we can exit from the bot. And we can see here now we're shutting down that direct connection from both the controller and the bot, and the Wrangler is handling that. And now we can fire off an SFTP connection to that bot again. Again, this is the same end-to-end encryption system. We do a PWD, we can see I'm on desktop, we can do an LS, and here we can see we can see my notes, we can see my old Sentry project that I used to work on, and this was my Zero Trust SSH proxy project that I worked on a while ago. So for example, we can now run the get command for that. We can hit enter, and there we go, download complete, and that has retrieved that file. So you could use this for exfiltrating, data and stuff like that. Close that down, close down SFTP connection, and yeah, that's basically it. Close that down, bring this back up again. So that's what I've been working on for a while now. Don't really know how to sign this off, but thank you for watching. I'm going to continue working on this project, and yeah, we'll see where it goes.